Alright, Crewton Ramone's HowsAMath.com. There's a lovely shot of Molokai in the background. West Maui Mountains, here's Waihe Ridge right there. The peaks of Morotoi, Nokaheke, right there. It was a lovely sunset and I tried to capture it, but it's very difficult. Anyway, let us move on to mathematics. Speaking of island beauty. These girls, 14 years old it turns out. I thought the girl was like 16 or something, but it turns out they're 14. She invited a couple of her friends to come and play math with us. So there we are, fooling around, playing blocks, learning algebra. And it's an amazing thing to me. These two, this one and this one, are in a superior class to this girl here. But they're both, this one's getting a C, this one is getting an F. And I explained to her, my first grade in calculus was an F. I know exactly what an F feels like. You don't have to, I know, I can relate, let's put it that way. And again, we had a little talk about self-esteem. Do you need self-esteem to be successful? Yes. Do you need the math, especially this algebra and so forth, to be successful? If you're going to be in engineering or, doctors, scientists, a few other things, you're definitely going to need more mathematics. But, you want to be a photographer or, a few other things that they talked about wanting to be when they grow up. The math probably isn't going to be that crucial to them unless they want to get college degrees and so forth. They're going to need a lot more math, right? But is the self-esteem essential to achieving goals in life? Well, then the idea is to get out of math without damaged self-esteem. And as we progressed, I could tell, especially the one girl that had the F, was classic symptoms of math phobia, or not just afraid of the math. The symbols were starting to freak her out. Easy stuff becomes hard when you've been told by the institution that you're an F student, or that you're not smart, or that you're failing. So anyway, here we are fooling around with algebra. So some of those of you that are familiar with it will see. And here's the other thing too: is I always forget to bust the camera out. We went for like 2.5 hours, and my bad too. We went too long. I should have stopped earlier, but they were eating it up. So I went further, and I broke some of my own rules about always leave them wanting more and so forth. But they've got a lot of ground to cover, and I only get like 1 hour or 2 hours a week with them. So I tried to cover a lot more, and I probably went a little bit long by the time it was done. But anyway, there is x squared, 7x, and 10, and there it is factored. And see, she's using. See, if this was a little kid, it doesn't apply to the older students. Like these are 14-year-olds, but they would be getting the add-ins for 5. Like there's a 4 and a 1, 4 and a 1, and they can see that 10 is 2 times 5, and so forth. And then here they get the add-ins for 7, 2, and 5. So really, you can teach the algebra. Or excuse me, you can teach basic operations and add-ins and multiplication and so forth, the quote-unquote, beginner math, using algebra. Repeat this constantly. And you can also find out how good the skills are of the older students by using algebra, because sometimes they have difficulty. So here's x squared, 8x, and 15. And there's a very creative way to make it. Instead of using 3 5s, she packed a bunch of 2s and a 1 in there. And I was laughing at her because I'm like, how do you make 15 with 2s? And so anyway, there it is. There's the 1 that turns it into 15, 14, and 1 more. But instead of using 3s, right, could have used 5 3s. Anyway, I just thought it was a very creative way to solve it. She's just getting to understand that if I want to factor x squared, 8x, and 15, I need 3 and 5. And again, there's add-ins. And here's that other girl who, like I said, she's not in the class, so she's basically there to support her friend, I basically told her, look, it would be more fun if you had more friends here to learn the algebra, because just me and you, it's no fun playing in your sandbox alone, so get a couple of friends. So she enlisted these two, and we had a fun time, really. I mean, we did a lot of laughs, a lot of chuckles, a lot of goofing around. Right, zero tears, no fear. They were seeing that, oh yeah, this is actually pretty easy. And of course I'm telling them stories about, how little kids can do this exact same math, right? Not to belittle them, but to make them understand that really it is that simple. Here's the rectangle, here's the sides. No symbols here, or excuse me, no pictures here, just symbols. What they totally got. Yep, here's the rectangle, here are the sides. Here's the rectangle, here's the sides. And it turns out this girl was starting to get them faster than the other two. Why? Because she's not invested. Right? She's in a different class. She's just having fun, fooling around. So there's no anxiety, there's no, there's no filter in her mind saying this is hard, or I better get this right because I got a C or an F and I need this tutoring and so forth. She's just there having fun, and lo and behold, she starts to excel, right? Much to the chagrin of her friends, I assure you. Anyway, so there they are fooling around with math. Like I said, by the time I took the camera out, we fooled around with exponents. There's all kind of stuff I could have used on my screencast and blog to cover more topics of, typical high school algebra textbook. But of course, I need a cameraman is what I need. Anyway, there she is having fun, fooling around, getting them right. Right? And it's, like I said, we a lot of laughs, it's fun when you're learning. And it doesn't have to be, a bunch of, laborious problems that you're doing. You can actually, do some exercises and practice. Different way to look at it. Anyway, here's, I'm not going to use their names, but anyway, this girl, they're fooling around, getting the problems. She was definitely in her mind thinking this is hard, and she made it hard. When she thought it was easy, it was easy. And when she saw that her friend here, who was, like I said, is in not as an advanced math class, was getting them faster than she was, this was good motivation. And this is yet another reason why I like to have group sessions with children, because they motivate each other. There's a natural competition among humans. We can't help it, right? Lots of teaching methodologies try to minimize that, but there's always going to be competition, and the thing, you can make that a positive aspect of human nature or a negative aspect of human nature. I consider it a positive aspect, because once the one girl could see that the other girl was getting it, then she's thinking, well, if she gets it, I can get it, right? Makes it so that, no detriment to this girl, or, taking away nothing from this girl, she was just saying, if she can get it, I can get it, right? And so it helps everybody learn. It helps everybody get it. It makes it easier. And, gee, do they look like they're struggling and crying? That's not, she's not crying. It's fun. We're getting it. We're having a fun time factoring. And see, once they got it, once we got a few problems under their belt, then boom, I can start putting problems down: x squared 9x and 20, x squared 9x and 18, x squared 10x and 21. Right? And we had played a bunch of completing the square before this, because their textbook has several pages of completing the square. So we did a bunch of completing the square. So they all knew that 10x, or x squared plus 10x, that 25 would complete the square. I said, well, what if it was 21? And they had to use 3 and 7. And they started to see that how that worked. 3 times 7, 21. 3 plus 7, 10. Right? You can see the light bulbs going off. And then we started fooling around with negative numbers, and I took this shot for you. Right, there's x plus 7, x minus 2, and you see there's the symbols, and we don't have the blocks put together. But anyway, I want to drive this point home, because I drove it home with one of the students, because she asked me. I asked, is plus negative the same as minus? And she wasn't sure. So we talked about combining, and the concept that there's not really any addition or subtraction. You just combine. So you can add a negative, and that's the same thing as taking away. And you can really see it with the blocks. I put this on top, and I said, look, there's 10 minus 7. And then here we combine them another way, where I have 10 plus negative 7. Either way, you're going to wind up with 3. Right? And making sure that they understand that these symbols mean exactly the same thing. And then we talked about these two symbols. These two symbols in mathematics, you go through. I've seen kids in college and high school students, but even up to college, even some teachers, where I ask them, what do these symbols mean in mathematics? And if all you get is plus and minus, positive and negative, well, your understanding of mathematics is going to be very limited, and life is going to be difficult for you, especially when you get up into the calculus and other things, other areas, because these symbols show a relationship, because math is the study of relationships. In addition to being a language and other things, it's another definition of it. We're just studying numbers and relationships between those numbers. But math is just counting when you get down to the very basics of it, and then we can talk about the relation, the relations between the things that we're counting. But if this is hot, then this is cold. If this is up, then this is down. If this is light, then this is heavy. No, wait, that's a joke. If this is light, then this is dark, right? Aperture in a camera. If this, right? Okay, so what is the relationship between those two things that we're talking about? And the relationship between those two things is the concept of opposites. So now we can start talking about zero, right? Because if I have a number and its opposite combined, I get zero. And that's an identity. But anyway, we didn't get into that. But anyway, just understanding that plus and minus means more than just plus or minus or add and subtract, right? And the concept of combining, not two separate operations of addition and subtraction. There's only combining, sticking stuff together. And we use this symbol or this symbol to decide which way, how we're going to combine. And then we fooled around with, well, what if I just had this? What if and see, with my other student, with a little self-directed kid, remember 6th grader, he was able to do this, and I've had some 8-year-olds just, draw some pictures and talk about them using the symbols. So here we are 2x this way and 3x plus 1 this way. This actually threw them for a bit of a loop. Right, and trying to get them to understand the distributive there, that I multiply this times this, I get these. And when I multiply this times that, I get these 2x here. Right, so the answer is 6x squared plus 2x. Okay, so the idea being, and I've seen students and adults where they have a hard time seeing 2x times 3x would give you 6x squared. Right, so we were using, to put the blocks aside and drawing some pictures in their notebooks. And it was pretty interesting to see how how it came out, especially with the knowledge that I've been working with younger kids doing exactly this same thing, where I know the older kids can do it. They just have some mental blocks, in the form of F's on tests. See, and that's the other thing. They're coming to tutoring. Now, if they knew everything, would they need tutoring? Right? I mean, we were talking about that too. It's like they already have a preconceived notion that maybe there's something wrong with them, or maybe they can't get this stuff because they're because they're getting tutored right there. So I have to overcome that too, and so do you as teachers or tutors. That they're there to have fun, yuck it up, enjoy yourselves, right? Even if it's high school algebra, you can still have a good time. And we did. I'm serious. We laughed a lot. I don't have enough pictures of that, but here. You can go to the password protected pages and we'll show you how this works right here. And you see partially completed distributive there where you have some negative factors. Anyway, and then after we got done with all that, see, all in one lesson, this was their first exposure, and I don't usually go from positives and the negatives the first time they see it. I usually spend some time with, they get a bunch of experience with positives, and then we move into negatives. But like I said, because I only get a little bit of time with them, they, it's a terrible picture. And so is that. But anyway, but you can see the one thing you can see, even with their eyes closed, is over that they're all smiling. We had a fun time. It wasn't drudgery, and nothing terribly hard about it. But it was their first exposure, and in 2 hours, we covered a lot of ground. So, if you want to see more of this kind of, stuff, get yourself a password, and maybe I'll make a screencast about it. But anyway, the idea being is, if you have an enjoyable, fun time, you can teach a lot, and more kids is better than fewer kids. Like, you don't want to have too many kids. Like, they're in a class of 30, and that poor teacher is overwhelmed with that many students. But if if you're tutoring, 3 or 4 is better than 1. It really is, because you get the group think going on, and you need to control that group think to make sure it's fun. But you get the competitive nature. It's just much more enjoyable, and you can cover a lot of ground faster. Anyhow, go to CrewtonRamone'sHouseOfMath.com for more. Get yourself a password if you want to see how to do more, much more in-depth explanations of negative numbers and negative expressions and third power algebra and so forth. Crewton Ramone's House of Math.com.